નમસ્કાર, હું આદર્શ છું. વેલકમ ટુ આદર્શ એજ્યુકેશન સોસાયટી. Good morning, students. Today we are going to talk about statistics, chapter 14, standard 10th. In 9th standard, we have studied statistics, measures of central tendency for ungrouped data. Now here we are going to talk about measures of central tendency for grouped data, that is numerical representatives of the given data, that is called measures of central tendency, that is mean, median and mode. So for grouped data we are going to talk about these three things. Here for data given, if it is continuous frequency distribution with equal class length, last year we have discussed regarding continuous frequency distribution, discrete data. So here there we will have the two types of continuous frequency distribution, with limits and with boundary points. So for that we need to find out class mark or the mid value or the central value. So that is equal to upper class limit plus lower class limit divided by 2. If it is with boundary points, upper boundary point plus lower boundary point divided by 2. So these are the things we have studied. Now today we are going to talk about mean of the grouped data only. So here we are going to talk about only mean. Mode and median. So now after mean we will discuss mode and median. So let us go for mean of the grouped data. So in this there are three methods: direct method, assumed mean method and step deviation method. So here we are going to talk about first of all direct method. Assumed mean method and direct method we can go for discrete data also, but step deviation we can go for only continuous frequency distribution, when there is a continuous frequency distribution. So first of all direct method. So direct method already you studied. Mean of the data is equal to summation of all the observations divided by number of observations, that we have studied. But here it is discrete data, that is for ungrouped data. Now for discrete data there are frequency and observations. So product of this frequency and the observations, that is fi xi. So that summation of this product, that is sigma fi xi divided by sigma fi. Sum of all the frequency is equal to number of observations in the data. So that is direct method. Now assumed mean method, we have to go for A assumed mean. Xi means each observation, x1, x2, x3 and so on. So these are the observations, and Di means deviation for each observation. So each observation minus assumed mean we will get deviation. So using this deviation now, that is called deviation method. So mean is equal to deviation plus summation of the product of frequency and the deviation for each observation, that is sigma fi Di divided by sum of frequency, that is number of observations. So let us derive this for assumed mean method. So here you can see relation between deviation and mean. Mean of deviations, that is d bar, that is summation of fi Di. How we got here mean sigma fi xi? So mean of deviation sigma fi Di divided by sigma fi. As we know, deviation is equal to each observation minus assumed mean. So deviation is equal to each observation minus assumed mean. Sigma fi Di, so sigma fi xi minus a, denominator as it is. Now removing the bracket sigma fi xi and then sigma fi a, then we get sigma fi xi upon sigma fi and sigma fi a upon sigma fi. So a is constant, so a multiplied by sigma fi upon sigma fi. So this is equal to what? Nothing but direct method. You can see sigma fi xi, that is x bar. Here we will get sigma fi xi upon sigma fi. So that is equal to x bar, and here a multiplied by 1, that is minus a. So we got deviation bar is equal to x bar minus a. So x bar, that is mean, is equal to a plus deviation bar. So what is deviation? Mean of deviation, that is mean of deviation is equal to this. So replacing this value here again, we will get this formula, that is mean using assumed mean method is equal to assumed mean plus sigma fi di upon sigma fi. Now third method, and then we'll go for sums based on this. Third method, step deviation method. Here deviation, but one more step extra. That is, your mean is equal to assumed mean plus h for class size or class length, in bracket sigma fi ui upon sigma fi. So ui called step deviation, that is called each observation minus assumed mean divided by class size. So that is here deviation, step deviation. So now let us derive this relation also, that is mean is equal to assumed mean plus class length or class size, in bracket sigma fi ui upon sigma fi. So let us derive this relation. So now here relation between deviation and mean. Therefore here first of all mean of deviation, step deviation, mean of step deviation. What is mean of step deviation? That is here u bar, that is equal to sigma fi ui divided by sigma fi. So this is mean of step deviation. So now let us go for substituting the value here. What is u bar? That is step deviation. Therefore u bar is equal to, here we will get, substitute this value sigma fi ui. So sigma fi ui means, already we have written ui is equal to sigma xi minus a divided by height. So fi multiplied by this divided by sigma fi. So now what we will get on removing the bracket? Sigma fi, first of all here height. So we will get h, 1 by h common. Here denominator is h. So 1 by h common. So 1 by h common, that is we can write like this, sigma fi xi, sigma fi xi minus sigma fi multiplied by a whole divided by sigma fi. So now therefore we will get 1 by h common here. Is it clear? 1 by h will take common here, multiplied by, here you can see sigma fi xi divided by sigma fi minus, here sigma fi upon sigma fi and a is common, constant. So sigma fi upon sigma fi. So now therefore u bar is equal to 1 upon h, in bracket here sigma fi xi upon this, that is called mean x bar, and here a multiplied by 1. So we got this, and now simplifying this, what shall we do? H multiplied by we will get u bar is equal to x bar minus a, and therefore x bar is equal to assumed mean plus h multiplied by u bar, and therefore finally we will get x bar, that is mean, is equal to assumed mean plus class size or class length multiplied by mean of the deviation. That is, we have taken here mean of the deviation here, that is sigma fi ui, sigma fi ui divided by sigma fi, that sigma fi. So this is the final formula for finding the mean using step deviation method. So now we shall continue for sums based on this. Now exercise 14.1, question number 1. A survey was conducted by a group of students as a part of their environment awareness program, in which they collected the following data regarding the number of plants in 20 houses in a locality. So here 20 houses are there. Total number of houses 3 plus 2 plus 6 plus 5 plus 1 plus 2 plus 1. Number of houses 20. But here number of plants in a house 0 to 2. There are only one house. One house having these 0 to 2 plants, and 2 to 4 plants there are 2 houses, and so on. So this survey was conducted just for environment awareness program. So question is, find the mean number of plants. Find the mean number of plants per house. So per house, how many? What is the mean number of plants? So calculate the mean by direct method for this continuous frequency distribution. Let us proceed. So first of all, we have to make the table to find the mean. So here we can calculate the mean. First of all, number of plants, then number of houses. So here 0 to 2 plants. How many houses are there? There is only one house having 0 plants or 1 plant or 2 plants, or less than 2 plants. But here, if there are 2 plants or more plants, but less than 4, there are 2 houses. As you know, this is lower limit and this is upper limit, lower boundary point and upper boundary point. So upper boundary point is not included in the class. Then here 4 to 6, there is only one house having less than 6 plants, but 4 or more than 4. Then 6 to 8, 5. Then here 6, 2, 3, and total there are 20 houses. So 20 houses means what? This is nothing but sigma Fi, that is equal to n, and that is equal to 20. Is it clear now? So this we must know. Now what is the xi? That is called mid value or central value or class mark. So 0 plus 2 divided by 2, that is 2 by 2, and that is 1. Similarly 2 plus 4 divided by 2, that is 6 by 2, and 6 by 2 means 3. Then 4 plus 6, 10, 10 by 2, that is 5. So now as the class length, you can see equal class length. Here class length, how to divide 2 minus 2 and 4 difference, or 4 and 6 difference, or 8 and 10 difference, or lower boundary points 10 and 8 difference, or 6 and 4 consecutive, 2 consecutive lower or upper boundary points, or lower or upper limits difference is called class length. So here the class length is 2. So we can add 2. 1 plus 2, 3, then plus 2, then plus 2, then plus 2, then plus 2, and then plus 2. So we will get the central value or mid value. Now we have to go for Fi xi product. So 1 1 ja 1, 2 3 ja 6, 1 5 ja 5, 5 7 ja 35, 6 9 ja 54, 2 11 ja 22, and 13 3 ja 39. So now we have to make the total. 1 plus 6 plus 5 plus 35 plus 54 plus 22, and then plus 39, and that is equal to 162. So now we can find the mean. Therefore, mean is equal to sigma Fi xi by direct method upon sigma Fi. So now here, what is sigma Fi xi? That is 162 divided by, what is the sum here? 20. So now cutting the common ones, 2 10 ja, and here 2 81 ja, will get 81 by 10, and that is 8.1, and therefore we say x bar is equal to 8.1. So here what is 8.1? 8.1 is a mean number of plants per house. That is mean number of plants per house. So this way we can find out mean using direct method. Same way we will go for other methods also in this exercise. Thank you for joining us.